So there's the setup. Let's see how well, number one, my mnemonic device worked, and number two, how good your memory is. What are the 4 steps I have to go through to prove this by induction? You just want to be hard, don't you? Taped, okay. T-A-P-E. So the very first thing I need to do is test for what value? For the first one, or the lowest one, right? Which in this case, I guess would be 1, right? Okay, so let's give this a go. I'm actually going to write out what I'm doing rather than just have lines of arithmetic. So I'm going to say test for n equals 1. Okay. So here's my left-hand side. I'll just say it's equal to. And the left-hand side is usually pretty trivial, right? How many of these terms am I going to have if I go up to n squared? N is just 1, so 1 squared is equal to 1. Wow, dramatic, okay? Right-hand side. At least it's a little more work here. All the n's replaced with 1's, okay? So 1 over 6, 1 plus 1, 2 plus 1. That gives you a 6 times 2 times 3, which is 1. No dramas. Okay, next step. A for assume, right? So I'm going to assume the statement is true for n equals k, which is some arbitrary number, right? In other words, I'm picking one of the dominoes, any of the dominoes really, and then we'll look at the next one, okay? So I'll say, I can write it here, assume true for n equals k. By the way, do watch out, we're using k a lot, and if you're like me when you're in a hurry, your k's, you sort of write like this, right? And then when you're writing really fast, it turns into this, which turns into this, and then you're like, where did my h come from, okay? So just to, because you're writing a lot of k's, trust me, just to be a safeguard, let's go back to, when did you learn foundation? Is that like preschool? Kindy, okay? Write your line down and then draw that. That's not gonna turn into a h, I promise, okay? Unless you try really hard, okay? Anyway, so there's my k. Now, please don't write in the next thing, right? Don't write therefore, okay? Because this is not logically therefore I can imply something, right? There's no logic behind it. I'm just making an assumption, okay? So don't put therefore. I mean, it's not that you're going to lose marks for it, but it's kind of when I'm reading something, a proof by induction, because I know, or rather you know what you're meant to end at, right? There's no value on getting to the answer because you've already got the answer. All of the value is in what's in between. Right, and being able to demonstrate, I understand how this proof works. And if you say therefore, you don't really understand how this proof works, okay? So instead say, if I'm assuming it true for this value, what that means is, or what that looks like is, these values, all the way up to k squared, is equal to okay, done. And now the work begins, okay? Because P stands for proof. Proof for the next value, okay? So I'm going to try and use this side of the board. Give myself a little more room. Now, be careful how you write this next part, right? Make it easy for yourself to make the substitution, the by assumption step, okay? So instead of going 1 squared, 2 squared, 3 squared plus, and then make the last term k plus 1 all squared. That is the last term, okay? But I want to include the second last term as well, because then I've got this part here, which I can just swap out, okay? So I'm going to now prove for n equals k plus 1. So my next line, just to make it clear for me, okay, I say required to prove, so that I distinguish that from something I'm saying is true versus something I've got to actually establish, right? So I've got 1 squared, 2 squared, all the way up to k plus 1 squared, okay? Again, beginner's error, please make sure the k plus 1 that you sub in, the whole thing is being squared, right? It's very simple and very common for people in a rush to accidentally write, instead of k plus 1 all squared, they write k squared plus 1. That's the kind of error which we do when we're rushed, and it's very difficult to spot out, oh, this is wrong, because it looks okay, right? But it'll cause you algebra problems later on, so don't do that. I want to show that that's equal to this, but for k plus 1. Right? It would help if I wrote the right way. K plus 1. Okay. Now, again, it doesn't hurt to actually put in here 2 times k plus 1 in brackets plus 1. I'm just trying to save a little bit of space here, but every little arithmetic error counts. And a lot of the times when you ask for help, or I have trouble, right, it's not a problem in misunderstanding this, it's just some little thing like this, and you tear your hair out trying to search for a solution which is never going to work. Alright, so I'm going to start with the left-hand side and get to the right. So the left-hand side equals this. I just write it out verbatim. And then sometimes even just to make it clearer for me, right, I identify in another color the part that I can substitute with the inductive statement or by assumption, right? So this is the part that I can substitute out. Okay? You've got to be careful. Some of the examples I'm going to give you later on, or you might have seen, it's not just the first number of terms. Sometimes there's a term out the front which isn't included, okay, which doesn't belong here. So just be very watchful for what you're actually substituting. Okay? That we're assuming is equal to this. Okay, so I can sub that out. Okay, so that was my tricky step, and now I just have to do algebra. Now, as with before when you did, like, say, trig identities, or even when you're trying to prove, because this is what I'm thinking about for year 11, you've got to prove a function is odd, or prove a function is even. We're used to taking this, any algebraic statement, and just simplifying down as far as we can go, okay? But we don't actually want to simplify as far as we can go. We want to get to a specific point, and that might not be the simplest it can be, okay? So what I'm going to do is, before I do any working, keep my eyes on the target, right? Highlight it, this is where I've got to go, and think, what's the shortest path I can take to get there, okay? So for instance, I can see I've got a k plus 1 and a k plus 1 here, which I want to have out the front, right? So I'm not going to do any expansions or anything like that, even though I'm sure some of the terms will cancel out. That's not going to help me. It's going to get me further away from my goal rather than closer, okay? So I'm going to factorize by k plus 1. And put that out the front. So you can see here, all I've done is change the order to make it more obvious that I'm going in this direction. Okay? Now this guy here, I can't quite get it like that. I've got to multiply by something to get this on 6, right? So I'm going to go 6 k plus 1 all squared on 6. No real change, but just to make it easier to see what my factorization will be. Is that all right? Okay, so now I've got my common factor out the front. I've got k plus 1 on 6, and then what's on the inside? Well, here I'll have this. And then over here, what will I have? 6 lots of k plus 1. Okay. Alright, I'm almost there, right? This part out the front, I don't need to touch at all, because I know it's right. Okay, and this bit in here, I just need to expand, and hopefully if I haven't done any algebra slip-ups, it should all look good. k plus 1 on 6. Collect your like terms. Okay, now, this is one of the handy things about this being a proof by induction, because we already know where we're trying to end up. You can use some creative license. To go from here, I think it's not a leap to go straight to here, because that's just a good factorization. You don't need to get out like quadratic formula or anything like that. If you're good at factorizing, you could see that straight away. I'm not, so it's sort of, if I got this and you asked me, factorize this, I'd take a second to get there, but you already know where you're going to go, okay? And there's no intermediate steps if you were factorizing, okay? So, k plus 1 on 6 out the front, and your goal. Okay, again, let me stress. I think that's a legitimate transition to make, because what would you put in there? Like, what other lines would you put in there to make it clearer? I don't think there are any real extra ones. Okay, that's equal to my right-hand side. I'm out of space. Sorry. So I've finished step 3. What's my last step? What's the E for? I just have to explain. Which, as we saw before, these days doesn't take much. All I have to do, underneath all of this, is say, by the principle of mathematical induction, which is what we've been using, right? By the principle of mathematical induction, the statement's true. And the last thing you just have to be careful for is what values it's true for. Okay? So some of the examples I'm going to give you later today, if we get there, for things like divisibility, they're often true only for certain values and up. Here we're just n equals 1, sorry, 4, n equals 1, 2, and 3.